Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Alia Fanagadisam. My metric number is AW250047. I'll be explaining about this experiment 6, potentiometric pH titration identification. For the introduction, aspirin is a common medicine used to relieve pain, fever, and inflammation. Its active ingredient is salicylic acid or ASA, while other ingredients like cornstarch are added as fillers. Aspirin works by blocking the COX enzyme, which help reduce pain and inflammation. In the acidic environment of the stomach, aspirin can break down into salicylic acid. In this experiment, the amount of acetate salicylic acid in the commercial aspirin tablet is determined using an acid-base titration with a standard sodium hydroxide solution. For the objective, first to determine the precise amount of acetylic salicylic acid present in commercial aspirin tablet. Second, to utilize the standard sodium hydroxide solution, react with the aspirin sample until the neutral endpoint is reached. To compare the experimentally calculated mass of acetylic salicylic acid against the state on the product label. To evaluate whether the analyzed aspirin brands contain an acceptable mass of active ingredient based on industry standard tolerance within 5% of the labeled value. For part A, aspirin sample preparation, I'll be talking about result and discussion. As the result, as you can see at the table below, and the discussion is this experiment aim to separate the active ingredient aspirin tablet from insoluble ingredient using ethanol, distilled water, and filterization. The tablet masses was almost identical, around 0.137 gram, which shows good consistency between the tablet. However, powdered sample masses were different, probably because some powder was lost during grinding or transfer. Ethanol was added first because aspirin is soluble in ethanol. After adding distilled water, the mixture was filtered. The insoluble ingredients such as fillers and binders remain on the filter paper while dissolved aspirin passes through the filter. The filter paper has slightly different masses, which is normal because each paper has its own weight. Some experimental errors such as sample loss, incomplete dissolution, or wet filter paper may have affected the result. This error can be reduced by transferring the sample carefully, straining until the aspirin dissolves, and drying the filter paper completely before weight. Overall, the experiment successfully separated the soluble aspirin from the insoluble tablet ingredients, but careful handling is important to obtain more accurate and reliable results. For part B, titration of aspirin sample. For the result, you can see at the table I already stated that this experiment used acid-base titration to determine the amount of acetyl salicylic acid in aspirin tablet. Acetyl salicylic acid is a weak acid that reacts with sodium hydroxide in 1:1 ratio. Phenolphthalein was used as an indicator. The pH values of both brands were between 3.22 and 3.64, confirming that both tablets containing acidic acetyl salicylic acid. The results show that brand B required about 6.85 ml of NaOH, while brand A about 4.33 ml. This means brand B contained more acetyl salicylic acid. However, trial A1 and B3 were outliers because they required much less NaOH than the other trial. This difference were probably caused by sample loss, incomplete filtration, or errors during titration. Overall, brand B had a higher acetyl salicylic acid content than brand A, but some experimental error affected the accuracy of the result. Question 1. Calculate the active ingredient and in the aspirin in each trial. To determine the purity of aspirin sample, the mass of acetylsalicylic acid is recovered from titration was compared to the initial mass of the powdered table sample. The percentage of the active ingredient was calculated using the ratio of the experimentally determined mass of acetylsalicylic acid to mass of powdered sample multiplied by 100 to express it as a percentage. So as you can see there, there is active ingredient percentage equals to mass of acetylsalicylic acid over mass of powder sample times with 100. So the result is stated below. For question 2, calculate the volume of NaOH added at the moles of NaOH. The volume of NaO was recorded in ml and converted to liters to align with the molarity units. The number of mole in now dispensed when was then calculated by multiplying the volume to the titrant in liters by its molar concentration 0.1 m. Question 3. Calculate the acetyl salicylic acid that react with the NaO in the titrated sample using appropriate equation. So, the stoichiometry of the reaction between acetyl salicylic acid and sodium hydroxide is 1:1 ratio as represented by the following chemical equation. So given this 1:1 molar ratio, the number of mole acetyl salicylic acid present in the sample of stoichiometry equivalent to the number of mole of NaO required to reach the equivalence point. Mole of acetyl salicylic acid equals to mole of NaO. So after the calculation, as you can see at the table below, that is the answer. As question 4, calculate the gram of acetyl salicylic acid in the titrated sample using the molar mass acetyl salicylic acid. The mass of acetyl salicylic acid in the titrated sample was determined by multiplying the calculated number of mole of the acid by its molar mass, which is 180.16 gram per mole. So after the calculation, the answer is at the table below. Question 5. Acetylsalicylic acid as a content. So from the titration result, sample A contained an average of 81.06 mg of acetylsalicylic acid, while sample B contained of 111.70 mg. Since sample B required a larger volume of NaO, it indicates that it contained more acetylsalicylic acid. For question 6, which sample passes the industrial standard, which is 5%? So the result is sample A is acceptable while sample B is not acceptable. The pharmaceutical industry allows a tolerance of 5% from the labeled value. Sample A falls within the acceptable range, so it meets the quality standard. However, sample B exceeds the upper limits of 105 mg, so it does not meet the required standard.